Now here the question is, if the equation of parabola is 25 x minus 2 square plus y plus 5 whole square, and this is equal to 3x plus 4y minus 1 whole square, we need to find its focus, directrix, axis and tangent at vertex. And maybe we'll also find its length of lattice rectum. Now we know that any general equation of parabola can be expressed as PS equals PM, where PS is distance from focus and PM is distance from directrix. So I can write this equation as x minus 2 whole square plus y plus 5 whole square, and this is 3x plus 4y minus 1 whole square upon 5 square. So I can express it as under root of x minus 2 square plus y plus 5 whole square, and it will be 3x plus 4y minus 1 upon 5. So now it is of the form PS equals PM. So we can simply say focus of this parabola will be at 2 comma minus 5 and its directrix will be 3x plus 4y minus 1 equals to 0. So now we have focus and directrix for this parabola. We need to find equation of axis. Now we know that axis is a line which is perpendicular to directrix and which passes through focus. So that means for axis it will be a line which is perpendicular to directrix. So any line which is perpendicular to a given line, we can express it as 4x minus 3y plus k equals to 0, and this axis, it should pass through focus of this parabola. So I'll put the value of x and y. So I'll get 8 plus 15 plus k equals 0. So in that case, value of k is minus 23. So equation of axis of this parabola will be 4x minus 3y minus 23. It should be 0. We'll also need to write equation of tangent at vertex. Now tangent at vertex, it will be parallel to directrix and will pass through vertex. So what is the slope of directrix? So slope of directrix is simply minus coefficient of x upon coefficient of y. So there will be simply minus 3 by 4. So slope of this tangent at vertex will be minus 3 by 4. Now we'll also need to find coordinate of vertex. Now first what we'll do is we'll solve these two lines and we'll find base of directrix. So base of directrix will be so I need to solve these two lines. First line is 3x plus 4y equals 1, and the second one is 4x minus 3y, and that is 23. So I'll multiply the first one with 3 and the second one with 4. So I'll get 9 and 16. So there'll be 25x, and it should be 3 plus 92. So 25x, and this is 95. So here the value of x is 19 upon 5, and in the second case I'll multiply first one with 4, second one with 3, and I'll subtract. So then I'll get 25y, and this is 4 minus 69, so there'll be minus 65. So in that case value of y will be minus 13 upon 5. So base of directrix in this case will be 19 upon 5 and minus 13 upon 5. So that's the base of directrix, and we know that its focus is at 2 comma minus 5. So midpoint of directrix and focus is your vertex. So we'll take this midpoint. So vertex will be 19 by 5 plus 2 divided by 2, and then minus 13 upon 5 minus 5 divided by 2. So vertex for this parabola will be at, so this is 10, 29 by 10 comma, and here will be 25 and minus 13. So that will be minus 38 by 10. Now we need to write equation of this tangent at vertex. So equation of tangent will be y minus y1. So there will be y plus 38 by 10 equals to, what is the slope of this line? Slope of this line is minus 3 by 4 and then x minus x1. So there will be x minus 29 by 10. So I'll simplify, right? 10y plus 38 and this is minus 3 by 4 and that is 10x minus 29. So it will be 40y 152 and this is minus 30x and plus 87. So we'll get it as 30x plus 40y and this is minus 65. So we can write it as 3x plus 4y and this is minus 13 by 2. So that is the equation of tangent at vertex. Now we need to find length of latest rectum. So we know that distance from focus to directrix is simply 2a. So we'll find this distance. So we'll find distance of directrix from focus. So this distance is, so we'll put the value of this point. So I'll get 6 minus 20 minus 1 upon 5. So there'll be simply 3 and this 2a is equal to 3 and length of latest rectum is 4a. So I'll multiply it by 2. So length of latest rectum in this case simply will be 6. Now here the question is, consider the parabola y minus 2 square equals 4x minus 2 and x minus 2 square equals 4y minus 2 and let S be the largest circle touching the two parabolas internally. We need to find center and radius of this. So let us take another question and the question is, let S be the focus of parabola y square equals 8x. Now for this parabola we know what is the value of a? A here is 2. That means focus of this parabola is at a comma 0 which is 2 comma 0. And let PQ be the common chord of the circle x square plus y square minus 2x minus 4y equals to 0. And the given parabola we need to find area of this triangle PQS. So first we'll find points of intersections P and Q of this circle and this given parabola. So what we already know is any point on this given parabola, we can assume this point as some at square and 2at. A in this case is 2, so there will be 2t square comma 4t. Now we need to find those points on this parabola which are common with this circle. So what we'll do is we'll put the value of x and y in the equation of this circle. So now we can write 4t to the power 4 plus 16t square minus 4t square and then minus 16t equals to 0. Now here we can take 4t common. So if I take 4t common, then I can write t cube. And here what will I get? I'll get 12t square. So there will be 3t. And then minus 4 equals to 0. Now I'll take this cubic expression. So it is t cube plus 3t minus 4 equals to 0. So if I'll put t as 1, then I'll get 1 plus 3 minus 4 which is 0. So now we can use synthetic division. So this is 1 and this is 1, 0, 3 and minus 4. So it is 0. So it is 1, 1, 1 and then it is 1, 4 and then 4, it's 0. So we can factorize it as 4t, t minus 1 and then t square plus t plus 4 equals to 0. Now value of t can be either 0 or value of t can be 1. From this quadratic expression, we are not getting any real values of t. So the point of intersection of this circle and parabola, they are when the value of t is either 0 or when the value of t is 1. So if we'll put t as 0, we'll get p. So maybe p is 0, 0 and then q. If I'll put t as 1, then q is 2, 4. So now we need to find area of this triangle PQS. So we have this circle which passes through origin, and then we have this chord which is PQ. So this is P and this Q is 2, 4, and then we have focus of this parabola which is at 2, 0. So S, it is at 2, 0. So this height, it is 4 units, base is 2 units. So area of this triangle is half base into altitude. So it is 4. So area of triangle PQS is 4 square units. Let M be the foot of perpendicular from a point P on parabola y square equals 8x minus 3 to its directrix, and S is the focus of parabola. And if SPM is an equilateral triangle, we need to find length of sides of this triangle. So now we are given this parabola which is y square equals 8x minus 3. But in this question, what I need to find is, I'll just need to find length of side of this triangle. So without loss of any generality, what I can do is, rather than taking y square equals 8x minus 3, what I'll simply do is, I'll take this parabola as y square equals 8x. So I won't take x minus 3 because we just need to find length of this side. We are not supposed to find any particular point on this parabola. So it is the same question. So if I consider this parabola, y square equals to 8x. Then for this parabola, value of a is 2. So focus of this parabola, it is at a, 0. So it will be at 2, 0, and focus of this parabola is S. Then we have any general point P. So P is 80 square twice 80. So it will be 2t square, 4t. And then we have directrix which is at x equals minus 2. So let N be foot of perpendicular from a point P on parabola. So that's your M. So what is the coordinate of this M? So x coordinate is simply minus 2. And what is the y coordinate? Y coordinate in this case is simply 4t. Now it says this triangle SPM is an equilateral triangle. If this triangle is an equilateral triangle, we need to find length of side of this equilateral triangle. Now we know that in any parabola, PS equals PM. So these two sides, they should be equal. So we need to prove that this PS must be equal to SM. So PS is equal to SM. Now PS is focal distance. So we already know focal distance is A plus AT square. So it is 2 plus 2t square, and it should be equals to SM. SM is distance between S and M. So then it will be under root of 4 square plus, it should be 16t square. So I can write 2, 1 plus t square, and here I get 4 into under root of 1 plus t square. So I can cancel 2 with 2. So if we'll square, we can write this as 1 plus t square whole square, and this is 4 into 1 plus t square. So I can cancel 1 plus t square. So I can write t square as 3. So that is value of t should be plus or minus under root of 3. So we just need to find length of this side of equilateral triangle. So length of this side is equal to PS, and PS is 2 plus 2t square. So it will be 2, and then 1 plus t square is 3. So that is 8. So length of side of this equilateral triangle should be 8 units. Now the question is, the tangent is drawn at any point on parabola y square equals 8x, and on it is taken a point Q from which a pair of tangents QA and QB are drawn to this circle x square plus y square equals 8. So we'll draw this figure. So we have this circle, and then we have this parabola, that is y square equals 8x, and equation of this circle is x square plus y square equals to 8. Now it says a tangent is drawn at any point on this parabola. So let us take any point on this parabola. So suppose this is point P, which is AT square twice AT, and then from a point Q on this tangent, so we'll have to consider a point Q on this tangent, say Q, which is say alpha beta. Now from this point, a pair of tangents is drawn to this circle. Now using this information, we need to answer the following question. Now the first question is locus of point of concurrency of chord of contact AB of the circle x square plus y square equals to 8. Now we know that equation of chord of contact drawn from any point Q on this circle will be given by t equals 0. So we can write this equation as alpha x plus beta y minus 8 equals to 0. Now we can also write equation of tangent to this parabola at this point P. So equation of tangent to parabola at point P, it is given by ty equals x plus a t square. Now we know that this point Q, it lies on this tangent, so we can write this equation as alpha minus beta t plus at square, it should be 0. Now from these two given conditions, we can find this fixed point, which is point of concurrency of all the chords. So we'll take this x here, this is x, and coefficient of alpha here is 1, and this is equals to y upon minus t, and it is minus 8 upon at square, and a in this case is 2, so it will be 2t square. So we can write this x as minus 4 upon t square, and we can write this y as 4 upon t. Now we'll eliminate this value of t, so we can write this as x equals minus 4, and it will be 16, and this is y square, so its equation will be y square plus 4x equals to 0, and that's your option number C. Now the next question is the point from which perpendicular tangents can be drawn to both the given circle and the parabola. Now we know that perpendicular tangents can be drawn from director circle. So for this circle, if we'll write equation of director circle, it will be x square plus y square equals 2a square. So there will be x square plus y square equals 16, and equation of director circle in case of parabola is nothing but directrix. So equation of directrix for this parabola will be x equals minus a. So it will be x equals minus 2. Now the point from which perpendicular tangents can be drawn both to the given circle and parabola will be the point of intersection of director circle with directrix. So what I'll do is I'll put the value of x as minus 2. We'll get this as 4 plus y square equals 16. Y equals plus minus under root 12. So there'll be plus minus 2 root 3. So the points from which perpendicular tangents can be drawn to both the given circle and parabola will be minus 2 comma plus minus 2 root 3, and that's your option number D. Now the third question is locus of circumcircle of triangle AQB. So we have this point A, and then this point of contact is B. We need to find equation of circumcircle of this triangle AQB. So we know that circumcircle of triangle formed by pair of tangents and chord of contact will pass through center of this given circle. So that means this circle will pass through center of x square plus y square equals to 8, which is origin. So it is 0 comma 0, and this point is alpha beta. Now this angle A and angle B, it is 90 degrees. So it simply means this OQ, it is diameter of circumcircle. So if OQ is diameter of circumcircle, then we need to find locus of circumcenter. So let circumcenter be h comma k. So using midpoint formula, we can write alpha upon 2 equals h, beta upon 2 equals k. So from here we'll write alpha equals 2h and beta equals 2k. Now we already know that this alpha beta, they lie on this tangent, so which is alpha minus beta t plus a t square equals 0. So we'll put the value of alpha and beta. Alpha is 2h and beta is 2k. So we can write this as 2h minus 2k t and then plus a t square equals to 0. Now in the question, it is given that t is equal to 2 and a is also 2. So we can write this equation as 2h minus 4k and this is plus 8 equals to 0. So this equation will be h minus 2k plus 4 equals to 0, which is x minus 2y and then plus 4 equals to 0. So locus of circumcenter of this triangle AQB will be x minus 2y plus 4 equals to 0, and that's your option number C. Now the question is, tangent is drawn to parabola y square minus 2y minus 4x plus 5 equals to 0 at a point P, which cuts the directrix at a point Q. A point R is such that it divides QP externally in the ratio 1/2:1. Then find the locus of point R. So first we'll rewrite this equation. So I'll add 1 and subtract 1. So we can write this equation as y minus 1 whole square, and this is 4 x minus 1. So we'll compare it with the standard equation. We'll get y square equals 4 times capital X. Now we need to consider a point P. So for this, let us say this point P is at square. A in this case is 1. So it will be t square comma 2t. And now we need to write equation of tangent for this point P. So for this point P, equation of tangent will be ty equals x plus at square. A in this case is 1. So it will be x plus t square. Now we need to find this point Q which lies on directrix. So we know that at directrix, x is equal to minus a. So we'll put x as minus a. We'll get y as t square minus a upon t. So this point Q is minus a t square minus a upon t. So we'll need to find locus of this point R, which divides QP externally in the ratio 1:2:1. So that means we have this point Q, which is minus a, and I'll write this as t minus a upon t, and then P is t square comma 2t, and then we need to find this point R, which divides it in the ratio 1:2 ratio externally, and say this point is alpha comma beta. So we can write alpha as t square minus 2. What's the value of a? A is 1. So it'll be simply t square plus 2 upon minus 1. And what's beta? Beta is 2t minus 2 t minus 1 upon t upon minus 1. So here we can write t square equals minus alpha plus 2, and here 2 and 2t and 2t, it will cancel. So I'll get beta equals minus 2 upon t. So we'll eliminate t. So we'll eliminate t, we'll get 4 upon beta square equals minus alpha plus 2. So we can write this equation as alpha plus 2 into beta square equals minus 4. Now we'll change alpha with x and beta with y. So we can write this as capital X plus 2 capital y square, and this is minus 4. Now we know that capital X is x minus 1 and capital Y is y minus 1. So we can write x plus 1 y minus 1 whole square and then plus 4 equals to 0. So locus of this point R is x minus 1 y minus 1 square plus 4 equals 0. Now here the question is, a line y equals mx plus 3 meets y-axis at 0, 3, which is E. The arc of parabola y square equals 16x when y lies between 0 to 6 at the point F, x0, y0, and the tangent to parabola at F intersects the y-axis at G, 0, y1. The slope m of the line is chosen such that the area of triangle EFG has a local maximum. Then we need to find the correct match. So first we'll draw this figure. So we have this parabola, which is y square equals 16x, and then we have this line y equals mx plus 3, which intersects y-axis at this point E, which is 0, 3, and this parabola at point F, which is x0, y0, and we know that for this parabola value of a is 4. So we'll take this f in terms of parametric coordinates. So that is 8t square, 4t square, and then 2at. So it is 4t square, 8t. Now it says tangent at f intersects y-axis at G. So tangent at f intersects y-axis at this point G, which is 0, y1. So we can write equation of tangent in terms of parametric coordinates. So equation of tangent will be ty equals x plus at square, so which is 4t square. Now this point G, it lies on y-axis, so we'll put x as 0, we'll get y as 4t. So value of G is 0, 4t. Now we'll write area of this triangle EGF. So area of this triangle EGF will be half, and then this distance, which is 3 minus 4t, and then this height, which is actually equal to its x coordinate, that is 4t square. So we'll get this area as 2 and then 3t square minus 4t cube. Now we need to maximize this area. So we'll differentiate. So if I'll differentiate, we'll get d delta upon dt. So it'll be 2 and then 6t minus 12t square is equal to 0. So we'll get the value of t as either 0 or 1 by 2. So this is minus, plus, and minus. So we have a local maximum when the value of t is 1 by 2. So in this case, value of t should be 1 by 2. So what is the value of g? So g will be 0, 2. So that means y1, it should be 2. Now what should be f? F is 4t square, so which is 1, and then 8t, which is 4. So x0, it is 1, and y0 is 4. And if we have to find slope of this line, so what is the slope of this line? Slope of this line is, so we know that this point is 1, 4. So y2 minus y1 upon x2 minus x1. So value of m is 1. So this small m, it is mapped to 1, which is option number 4. Maximum area, so we'll just need to put the value. So we'll put the value of t as 1 by 2. We'll get this value as 3 by 4 minus 1 by 2. So it'll be simply 1 by 2. So maximum area will be 1 by 2. Y0, so maximum area, it is 1 by 2. What's y0? Y0 is 4. And what's y1? Y1 is 2. So it should be 4 1, 2, 3. 4, 1, 2, 3. And that's your option number A. Now the question is, two straight lines are perpendicular to each other. One of them touches the parabola y square equals 4ax plus a, and the other touches y square equals 4bx plus b. Now first we'll take this parabola, so which is y square equals 4a x plus a. So we'll compare it with the standard equation, capital Y square equals 4ax. Now for this parabola, we can write equation of tangent as t capital Y x plus at square. Now in place of y, we'll write y, and in place of x, we'll write x plus a. So it'll be ty x plus a plus a t square. So that's my first equation. Now for this second parabola, which is y square equals 4b x plus b, this equation will be t dash y equals x plus b t dash square. Now we'll need to find locus of point of intersection of two lines. Now we know that these two lines, they are perpendicular to each other. What is the slope of this line? 1 upon t, and it is 1 upon t dash. So from here we'll get the condition as t into t dash should be -1. Now we need to find locus of point of intersection of these two lines. So first what I'll do is I'll replace t dash with -1 upon t. So I'll get minus y upon t x plus b upon t square. So we can write this as minus ty, and this is x plus b into t square, and then plus b. So we can write this equation as x plus bt square plus ty plus b equals to 0, and this first equation as at square minus ty plus x plus a equals 0. Now we need to find locus of point of intersection of two lines. So this x and y, suppose it is the point of intersection. So I need the answer in terms of x and y. So I'll just need to eliminate this t. So what we'll do is we'll add the two equations. So we'll add the two equations, we'll get x plus b plus a into t square plus x plus b plus a equals 0. So I'll take x plus b plus a common, and then it is t square plus 1 equals to 0. So condition should be x plus b plus a equals to 0. So locus of this point of intersection of two lines should be x plus b plus a should be 0, and that's your option number 3. Now let us take very interesting rolling parabolas problem. Now the question is, the parabola x square equals 12y, which means this parabola, it rolls without slipping around the parabola x square equals minus 12y. So this parabola, it is fixed, and this parabola on the top, it is rolling without slipping around this second parabola. We need to find locus of focus of rolling parabola, and also we need to find locus of vertex of rolling parabola. Now these two parabolas, they are mirror image of each other about x-axis. So if we consider any point on this parabola, which is x square equals 12y, and say this point is A, and any parametric coordinate, it is 280 comma 80 square for this third form, and here in this case value of A is 3, so it will be 280, so it will be 6t comma 3t square. So if this parabola, it starts to roll along this fixed parabola, then it will cover the same distance because it rolls without slipping. So that means if it covers the same distance, then once this parabola, it rolls down, then in that case, this point A will come to this A dash, whose coordinate will be 6t comma minus 3 square. So basically now we can draw this parabola in this way. Now we need to find locus of its vertex and focus. Now clearly we can say that this parabola, once it has rolled down along this fixed parabola, it is nothing but it is reflection of this fixed parabola about tangent at this point A. Now we'll start solving the question. Now the first question, find the locus of focus of rolling parabola. Now focus of rolling parabola will be mirror image of focus of this fixed parabola, and focus of this fixed parabola is 0, minus 3. Now in one of the previous videos, we have already established this property that image of focus about any tangent to parabola will lie on directrix. So image of focus about any general tangent will always lie on directrix of parabola. So for this rolling parabola, its focus will lie on directrix of this fixed parabola. So which is y equals 3. So answer to this first question is locus of focus of rolling parabola will be along this line, and that is y equals 3. So this first part, it is very simple. Now we'll come to the second part. Now second part says we need to find locus of vertex of rolling parabola. Now vertex of rolling parabola, it is mirror image of vertex of this parabola about this tangent. Now once we have this point and we have equation of this parabola, we can write equation of this tangent. So equation of this tangent is given by t equals 0. So in place of x square, we'll write x into x1. So it'll be 6t into x and then minus 12, and in place of y, we'll write y plus y1 upon 2. So it'll be y minus 3t square upon 2. So now here 6 and 6, it'll cancel. We can write this equation as tx minus y plus 3t square. So equation of this tangent, which is t equals to 0, is given by tx plus y minus 3t square equals 0. Now we need to take reflection of vertex for this fixed parabola, and that is 0, 0 about this line, and it will give us the locus of vertex of rolling parabola. Now say this vertex is alpha, beta. So now we'll use formula for reflection. So we'll reflect origin about this line, then we can write alpha minus 0 upon t equals beta minus 0 upon 1, and this is minus 2. If we'll put x and y as 0, so it'll be 0 plus 0 minus 3t square upon 1 plus t square. So we can write alpha as 6t cube upon 1 plus t square, and we can write beta as 6t square upon 1 plus t square. Now we'll need to eliminate t from these two expressions. So what we'll do is we'll divide first by second. So then we can write alpha upon beta, and here 6 will cancel, 1 plus t square will cancel, and t square will also cancel. So we'll get alpha upon beta as t. Now we'll put the value of t in this second equation. Then we can write beta equals 6 alpha square upon beta square, and here it will be beta square plus alpha square upon beta square. So it'll cancel. So we can write this equation as beta into beta square plus alpha square minus 6 alpha square equals 0. Now in the end, we'll replace alpha with x and beta with y. So we'll get this locus as y into x square plus y square minus 6x square equals 0. And that is the locus of vertex of this rolling parabola. Now the question is, the straight line joining any point P on parabola to the vertex and perpendicular from focus to the tangent at P intersect at R we need to find equation of the locus of R. So first we'll draw this parabola. So this is y square equals 4ax, and then we have any point P on this parabola. So this is point P, which is suppose 80 square twice 80. Now straight line joining any point P to the vertex. So we need to join this P to O. So this is OP, and perpendicular from focus to the tangent at P. So we have this tangent at P. And then we have this focus, which is a comma 0. So a line from focus and perpendicular to this tangent. It intersects at this point R. We need to find locus of this point R. So what we'll do is, let's say this R is alpha comma beta. So we need to find relationship between alpha and beta, and we need to eliminate this parameter T. Now for this OP and R, they lie on a straight line. So that means beta upon alpha, that is slope of OR, must be same as slope of OP, which is 280 upon 80 square. So here A and A will cancel, T will also cancel. So we'll get T equals 2 alpha upon beta. So that's my first relationship. Now the second is, we'll find equation of this line. So we have a point on this line. We have slope of tangent. We know that slope of tangent is 1 upon T. So here slope of this line will be minus T. So we'll write equation of this line will be y minus beta minus T, and then x minus alpha, and this line, it passes through the point a comma 0. So I'll put y as 0. So I'll get minus b minus T, and then a minus alpha. So from here we'll write T equals beta upon a minus alpha, and that's my second equation. So now we'll eliminate this parameter T. So we'll get 2 alpha upon beta equals beta upon a minus alpha. So I'll get 2a alpha minus 2 alpha square, and this is equals to beta square. So this equation is 2 alpha square plus beta square minus 2a alpha equals 0. So which is 2x square plus y square minus 2ax equals 0. So this is the required locus, which is option number B. Now let us take some questions. We'll start with questions on general chord of a parabola. So we are given a parabola which is y square plus 4y, and this is equal to 4 by 3x minus 16 by 3. So what I'll do is, I'll complete the perfect square. So I'll add 4 both sides. So I can write this equation as y plus 2 whole square, and this is 4 by 3x, and then minus, so it'll be 12, 4. So again here will be 4 by 3. So I'll take 4 by 3 common. So I can write this equation as y plus 2 square 4 by 3, and this is x minus 1. And I'll compare it with the standard equation, which is capital Y square equals 4a capital X. So in this case, capital Y is y plus 2, capital X is x minus 1, and the value of a is 1 by 3. Now it says chords of parabola which subtends right angle at the vertex pass through a fixed point, and we need to find that fixed point. Now for this parabola, First we'll write equation of any general chord. So in previous video, we have already done this equation of a general chord. So equation of a general chord for this parabola, y square equals 4ax. It is given by t1 plus t2y equals 2x plus 2a t1 t2. So that is the equation of any general chord of a parabola. So we have this parabola which is y square equals to 4ax, and then we have this chord drawn at point P whose parametric coordinate is t1 and Q whose parametric coordinate is suppose t2, and this is t1 plus t2y equals 2x plus 2a t1 t2. Now we know that if this chord it subtends right angle at vertex, then first we'll find slope of OP. So what is slope of OP? So this point P actually is a t1 square twice a t1, and this point Q is a t2 square twice a t2. So this is 2 upon t1, and slope of OQ is 2 upon t2. Now since OP and OQ they are perpendicular, product of slope it is -1. So from here we can say the value of t1 into t2 is simply -4. So we'll put the value of t1 t2 here. So we can write t1 plus t2y equals 2x minus 8a. Now this chord it always passes through a fixed point, and what's that fixed point? So that fixed point is capital Y equals 0 and capital X equals 4a. Now what is capital Y? Capital Y is y plus 2. So we'll write y plus 2 equals to 0. So that means value of y is simply -2. And what is capital X? Capital X is x minus 1 and then 4a. What's 4a? So 4a in this case is 4 by 3. So 4 by 3 plus 1 is 7 by 3. So this point will be 7 by 3 comma -2. So chords of a parabola which subtend right angle at the vertex pass through 7 by 3 comma -2. Now here the question is, we need to find the values of m so that this line y equals to mx, it bisects two distinct chords drawn from 4 comma 4 on y square equals 4x. Now this point, it lies on this parabola y square equals 4x. So we'll draw this parabola. And then we have this point 4 comma 4, and it says two chords can be drawn from this point, and this line y equals to mx, it bisects the two distinct chords. So we have this line which is y equals mx, which bisects these two chords. So what I'll do is, I'll say, suppose this other end is at square twice at, and a in this case is simply 1. So it'll be t square comma 2t. Now we'll find midpoint of this chord. So what's the midpoint of this chord? So midpoint of this chord, it will be t square plus 4 by 2 comma 2t plus 4 by 2. So it will be t square plus 4 by 2 and then t plus 2. Now this midpoint, it lies on this line which is y equals mx. So we'll put the value of x and y. So we'll get y plus 2 equals m, and then x in this case is t square plus 4 upon 2. So we can write it as mt square minus 2t plus 4m minus 4 equals to 0. Now in the question it says two distinct chords. So that means there should be
two distinct values of t so that we can have two distinct chords for this given parabola. So how do we get two distinct values of t? So for two distinct values of t, clearly this quadratic equation should have two distinct roots. So that means in this case d should be greater than 0. So we'll find d greater than 0, so which is 4 minus 4m, and this is 4m minus 4, and it should be greater than 0. So I'll get 1 minus 4m square plus 4m greater than 0. So we can write this equation as 4m square minus 4m minus 1, and it should be less than 0. So I'll add 1 and subtract 1. So we can write this equation as 2m minus 1 whole square minus 2, and this should be less than 0. Now if we'll put m as 0, we'll get this value as minus 1. So this is correct. If we'll put m as 1 by 2, we'll get this as minus 2. Again, it satisfies the given condition. And if we'll put m as 1, again we'll get minus 1. But if we'll put m as minus 1 by 2, so in this case, it'll be 4 minus 2 plus 2. So then in that case, it won't be less than 0. So options B, C and D, they are correct in this case. Now here the question is length of chord of parabola y square equals 4ax, whose equation is y minus root 2x plus 4 root 2a equals 0. So we have this parabola, and then we have chord of this parabola, which is y minus root 2x plus 4 root 2a equals 0, and we need to find length of this chord. Suppose this is a and this is b. So we know that any point on this parabola, we can write it as at square twice at. So we'll find those points on this line which are of the form at square 2at. So we'll just put this value in the equation. So we'll get 2at minus root 2 at square and plus 4 root 2 a equals 0. So we'll cancel this a and we'll also cancel this root 2. So we can add this equation as root 2t minus t square plus 4 equals to 0, or t square minus root 2t minus 4 equals to 0. So we can write it as t square minus 2 root 2t and plus root 2t minus 4 equals to 0. So we'll get this as t plus root 2 and then t minus 2 root 2 comma 0. So value of t is either minus root 2 or value of t is 2 root 2. So now we have t1 and t2. So we know that length of chord is a mod of t2 minus t1 under root of t1 plus t2 whole square and then plus 4. So this length will be a. What's t2 minus t1? So it will be 3 root 2 and then under root of t1 plus t2 whole square. So t1 plus t2 whole square is root 2 square. So there will be 2 and then plus 4. So this length will be a into 3 root 2 and then this is root 6. So this length will be 6a into root 3, and that's your option number 4. Now here the question is the common tangents to the circle x square plus y square equals 2 and parabola y square equals 8x touch the circle at the points P and Q and the parabola at the points R and S. We need to find area of quadrilateral PQRS. So first we'll draw this figure. So we have this circle, center at origin and radius root 2, and then we have this parabola y square equals 8x. Now we need to draw common tangents to this circle and parabola. So it says the common tangents, they touch the circle at points P and Q, and they touch the parabola at points R and S. We need to find area of this quadrilateral PQRS. Now what we can do is, we can write equation of tangent to this circle. So for this circle, equation of tangent will be y equals mx plus minus r, which in this case is root 2 into under root 1 plus m square. And for this parabola, equation of tangent is y equals mx plus a. What's a? A is 2. So it will be 2 by m. So it's a common tangent. So that means these two equations, they represent the same line. So we'll compare the constant term. We'll write plus minus root 2 into under root of 1 plus m square, and it should be equals to 2 upon m. So we'll square. We can write it as m to the power 4 plus m square minus 2 equals to 0. So we'll get m square plus 2 into m square minus 1 equals to 0. So value of m here should be plus or minus 1. So equation of tangent will be y equals x plus 2 and y equals minus x minus 2. So we'll consider this tangent, which is y equals x plus 2. Now for this parabola, we can find this point of contact. So we know that in parabola, point of contact, it is given by a upon m square and 2a by m. So in this case, the value of r should be, so here a is 2, so it will be 2 and then 2 comma 4. And in the same way, for this point S, we'll put m as minus 1. Then if we'll put m as minus 1, we'll get this value as 2 comma minus 4. Now we need to find the coordinates of points P and Q. So for that, what we'll do is, we'll find foot of perpendicular from origin, which is the center of this circle, to this tangent. So we can write foot of perpendicular as x minus 0 upon 1, y minus 0 upon minus 1, and then minus, we'll put the value of x, y as 0, so 0 plus 2 upon a square plus b square, which is 1 plus 1, so it'll be 1. So we'll get x equals minus y, and this is equal to minus 1. So value of x is minus 1 and value of y is simply plus 1. So this point P is minus 1 comma 1, and from symmetry we know that this point Q should be minus 1 comma minus 1. Now we need to find area of this quadrilateral PQRS. So basically it's a trapezium. So what is the length of the side PQ? So length of PQ is 2 units. What is the length of RS? Length of RS is 8 units. And what is this distance? So this is suppose H. So H in this case is, so it starts from minus 1 and 2. So this is 3. So what is the area of this trapezium? So area of this trapezium will be half sum of parallel sides, which is 2 plus 8 into 3. So it should be 15 square units. So that's your option number D. Now let us take another question. And the question is, if the locus of centers of family of circles passing through vertex of parabola y square equals 4ax and cutting the parabola orthogonally at other point of intersection is 2y square plus x square minus 12ax, and it is equal to ax kx minus 4a whole square, we need to find the value of k. So we have this parabola, which is y square equals 4ax and then we have this circle which passes through vertex, which is origin, and which intersects this parabola orthogonally. So we'll draw this circle, and suppose it intersects this parabola at this point P, and coordinate of this point P is say 80 square 280. Now we need to find locus of center of this circle. So since it is a locus problem, first step is identify the point. So let the center be say H, K. Now it is given that these two curves, they intersect each other orthogonally. So that means angle between their tangents is 90 degrees. Now since angle between the tangents is 90 degrees, so it simply means tangent to this parabola at this point P will actually be a normal to this circle. So center of this circle will lie on tangent drawn at this point P. So for this parabola, we'll write equation of tangent. So we write equation of tangent at this point P. So at this point P, equation of tangent is given by Ty equals x plus at square. And since center of the circle will lie on this tangent, so we can write kt equals h plus at square, and we'll write it as a quadratic equation in t. So we can write this as at square minus k into t plus h equals to 0, and that's our first equation. Now we'll get the second result from the fact that distance of these 2 points from the center must be same. So basically OC must be equal to OP. Now OC is h square plus k square, and OP will be h minus at square whole square plus k minus 2at square. Now here h square k square will cancel. So here we'll get a square t to the power 4 minus 2ah t square, and then plus 4a square t square and minus 4a t into k equals 0. Now here we can take at common. So if we'll take at common, then we'll get this equation as at cube, and plus here we'll get 4a minus 2h into t and minus 4k equals 0. So we'll get this equation as at cube plus 4a minus 2h t minus 4k equals 0. Now we'll need to eliminate this t. So what we'll do is we'll take this at square and we'll put the value of at square in this first expression. So we'll take this t common, and then we'll write at square as kt minus h. So it'll be kt minus h plus 4a minus 2h into t minus 4k equals 0. So we can write this equation as kt square. Now this is minus h into t minus 2h into t. So we'll write it as 4a minus 3h into t minus 4k equals 0, and that's our second equation. Now we need to eliminate t from these two equations. Now basically what we'll do is we'll assume these two equations as linear equation in t square and t. So we can solve these linear equations. So we can write t square, and this is b1 b2, so it'll be minus k, and here it is 4a minus 3h, and then c1 c2, it will be h and minus 4k, then h and minus 4k, and here it will be a and k, and first it will be ak, and then it will be minus k 4a minus 3h. So we can write this as t square upon 4k square minus 4ah plus 3h square, and this is t, this is h into k plus 4ak and here it will be 4a square minus 3ah plus k square. Now we'll equate these first two expressions. We'll get t as 4k square minus 4ah plus 3h square upon h plus 4a into k, and from this second and third expression we'll write h plus 4a into k, and this is equal to 4a square minus 3ah plus k square. So this is our required locus, but then we'll have to put it in the form which is given in the question. So we'll need to cross multiply. So we'll cross multiply, we'll get 16 a square k square minus 12 ah k square plus 4k to the power 4 minus 16 a cube h plus 12 a square h square minus 4ah k square, and then plus 12a square h square minus 9ah cube plus 3 h square k square, and it is equal to k square, and this is h square plus 16a square plus 8ah. Now from these two sides, 16a square k square and 16a square k square will cancel. Now we'll take terms of k together. So it will be 4k to the power 4, and then we'll have minus 12ah k square minus 4ah k square. Then we'll have 3h square k square and h square k square. So it will be plus 2 h square k square, and then we'll have minus 12ah k square minus 4ah k square and minus 8ah k square. So there'll be minus 24 ah into k square. Now whatever remains, we'll take it on right hand side. So we'll have 16 a cube h plus 12a square h square and 12a square h square. So it will be minus 24 a square h square and then plus 9 a h cube. Now here what we'll do is here we'll take 2k square common. So if we'll take 2k square common, we'll get 2k square plus h square minus 12ah, and here we'll take ah common. So we'll take ah common, we'll get 16a square minus 24ah plus 9h square. So this is 2k square plus 2k square plus h square minus 12ah, and this is ah, and it will be 3h minus 4a whole square. Now in the end, we'll replace h with x and k with y. So we can write this locus as 2y square plus x square minus 12ax, and this is ax, and 3x minus 4a square. So 2y square plus x square minus 12ax, ax, and 3x minus 4a whole square. So we need to find value of k, and k obviously in this case is simply 3. So value of k is 3, and that is the answer to this question. Now here the question is, P is a point P on parabola, y square equals 4ax, and PQ is the focal chord, PT is a tangent at P, and QN is a normal at Q. Then if the angle between PT and QN be alpha and the distance between PT and QN be D, then we'll need to find the value of alpha and D. So we'll draw this parabola. Now P is any point on this parabola, which is AT square 280, and then we'll draw a tangent at this parabola. So PT is tangent at P. Now it also says this PQ, it's a focal chord. So we have this PQ and it's a focal chord. So it passes through A comma 0 and Q is A T2 square twice A T2, and since PQ it is focal chord, we know that T1 into T2 is equal to minus 1. Now we draw normal at Q. This is tangent at Q and then we have normal at Q. Suppose this is QN. Angle between PT and QN, it says this angle is alpha and D is the distance between PT and QN. We need to find the value of alpha and we need to find the value of D. Now it is given that T1 into T2 is minus 1. Slope of PT is equal to slope of tangent, and slope of tangent is 1 upon T1. Now at Q, what is slope of normal? So slope of normal is simply minus T2. We can write minus T2 as 1 upon T1. So it is also 1 upon T1. So basically these two lines, they'll be parallel. So that means clearly in this case, value of alpha should be 0. Now, if the value of alpha is 0, then we need to find distance between these two lines. So we know that equation of tangent at this point P will be Ty equals x plus at square, or T1y equals x plus at1 square. Now what is equation of normal at point Q? Equation of normal at point Q will be y plus T2x equals a T2 cube plus twice a T2, and we know that T2 is minus 1 upon T1. So we can write this as y and then minus 1 upon T1x, and this is minus a upon T1 cube minus 2a upon T1. So we can rewrite this equation as T1y minus x, and this is minus a upon T1 square and then minus 2a. Now we need to find distance between these two parallel lines. So distance between these two parallel lines will be C2 minus C1. So we can write a T1 square and then plus a upon T1 square plus 2a upon and then under root of a square plus b square. So it will be T1 square plus 1. So we'll take a common. We can write this as T1 plus 1 upon T1 whole square upon under root of 1 plus T1 square. So here it will be a, and then we can write this as T1 square plus 1 whole square upon T1 square and then under root of 1 plus T1 square. So we can write this distance as a, and then it will be T1 square plus 1 to the power 3 by 2 upon T1 square. So value of alpha should be 0 and value of D should be a T1 square plus 1 to the power 3 by 2 upon T1 square, which is your option number B. If normal at P on y square equals 4ax cuts the axis of parabola in G, and if S is focused, then SG is equal to what? So we have this parabola, which is y square equals 4ax. Then at any point P, we draw normal, which cuts axis at this point G, and suppose focus is S, which is a comma 0. Now we know that at any point P, which is say at square 280, equation of normal is y plus xt equals at cube plus 2at. Now this normal, it intersects x's at g. Now that means for g, its y coordinate is 0. So its x coordinate will be at square plus 2a. So coordinate of g will be at square plus 2a comma 0. Now we need to find this distance sg. So this distance sg is simply at square plus 2a and then minus a. So it will simply be a plus at square. So that is a 1 plus t square. And we know that this is focal distance, which is equal to simply sp. So that means answer to this question is option number 1. Now the second question is, if normal at P cuts the axis of parabola in G and S is the focus of parabola, if this triangle SPG is equilateral triangle. So that means this triangle, it is an equilateral triangle. Then we need to find length of each side. This distance SG must be equals to PS and it must be equals to PG. Now this SG and PS, they are equal and we know that it is A plus AT square. So it is A plus AT square. And what is this distance? So this P is AT square comma 2AT and G is A plus AT square comma 0. So this distance will be under root of A square plus 2AT square. So we'll write a square and this is 1 plus t square whole square and it will be a square and this is 1 plus 4t square. So this a square will cancel. So we can write this equation as 1 plus t to the power 4 plus 2t square and this is 1 plus 4t square. So if we'll take this 4t square on the left, then it will be 1 plus t4 minus 2t square. So we can write it as t square minus 1 whole square equals to 1. So it will be t square minus 1 equals plus 1 or minus 1. So we'll take plus 1. Then we'll get value of t as plus or minus root 2. And if we'll take minus 1, then the value of t, it will be 0. If t is 0, it won't form a triangle. So that means the value of t should be plus or minus root 2. So now we need to find length of this equilateral triangle. So we know that this length of equilateral triangle is a plus at square, a1 plus t square. What's t square? T square in this case is 2, which is simply 3a. So length of side of equilateral triangle is simply 3a. Now here the question is, AB is the chord of the parabola y square equals 4x such that normals at A and B intersect at a point C 9, 6. So for this parabola, if we write equation of normal, it will be y equals mx minus am cube. Now a in this case is 1, so it will be simply m cube minus 2m. Now it will pass through this point 9, 6. So here y is 6 and x is 9, so it will be 9m minus m cube minus 2m. So we can write this as m cube minus 7m and then plus 6 equals to 0. So we'll write this as m cube minus m and then minus 6, m minus 1 equals to 0. So we can take m minus 1 common and then we'll get m square plus m minus 6 equals to 0. So it will be m minus 1 and then m minus 2, m plus 3 equals to 0. So we'll get 3 values of m. Either the value of m is 1 or m is 2 or the value of m is minus 3. So these 3 points, they represent co-normal points and their slopes are 1, 2 and minus 3. So now we have this parabola which is y square equals 4ax. And then we have this point C which lies on this parabola. And then we have these foot of normals. So we can find foot of normals which are am square minus 2am. Now here the value of a is 1. So if m is 1, we'll get this point as 1 comma minus 2. If m is 2, we'll get this point as 4 comma minus 4. And if we'll take m as minus 3, then we'll get this point as 9 comma 6. So that means this point C is 9 comma 6, and then we have 2 points, one of which is 1 comma minus 2, and that's your suppose A. So A is 1 comma minus 2 and B is 4 comma minus 4. Now first question is we need to find length of AB. So length of AB, it will be under root of, now this is 3 square 9 and then it will be 2 square 4. So it should be under root of 13. So this A, it is matched to R. Second one is area of this triangle ABC. So we can find this area as 1 by 2. Now x1, y1, 1. So it will be 1 minus 2, 1. 4 minus 4, 1. And then 9, 6 and 1. Now we'll take R1 minus R2 and R2 minus R3. So we can write this as 1 by 2 will be what? Minus 3 plus 2, 0. And now here it will be minus 5, minus 10, 0. And this is 9, 6 and 1. So we can write this area as 1 by 2 will be 30 and plus 10. So that should be 40 and it is 20. So area of this triangle ABC is simply 20 units. So option B, it is matched to B. Now third one is perpendicular distance from origin of this line AB. So here we'll need to find equation of this line AB. So first we'll find this slope. So its slope will be y2 minus y1. So it will be 2 and upon minus 3. And we can write this equation as y plus 2 minus 2 by 3 x minus 1. So it will be 2x plus 3y plus 4 equals to 0. Now we'll find its perpendicular distance from origin. So perpendicular distance from origin will be 4 upon, now it will be what, 9 and plus 4 root 13. So it will be 4 by root 13. So C, it is matched to Q. Now the last one is area bounded by the coordinate axis and the line through AB. So we'll find intercepts. So the modulus value of intercepts will be 2 and 4 by 3. So once we have these intercepts, we can write this area as half AB. So it will be 2 into 4 by 3. So option D, it is matched to S. Now here the question is, we need to find locus of midpoint of chord of parabola y square equals 4ax when it passes through focus. So that means we need to find midpoint of focal chord of a parabola. We know that for any parabola, if we are given midpoint of a chord, then equation of chord is given by t equals s1. So what we'll do is, we'll take this midpoint as some p and say it is alpha comma beta. Now for this chord, we'll find t equals s1, which is the equation of this chord. So equation of this chord will be t will be beta y minus 4a x plus alpha by 2, and it will be equal to beta square minus 4a alpha. We can write this equation as beta y minus 2ax minus 2a alpha, and this is beta square minus 4a alpha, or beta y minus 2ax minus beta square plus 2a alpha equals 0. Now first question is, it passes through focus. So if it passes through focus, that means it'll pass through a comma 0. So we'll put x as a and we'll put y as 0. So it'll be minus 2 a square minus beta square and plus 2a alpha equals 0. Now we'll replace alpha with x and beta with y. So we'll get this locus as y square equals 2ax minus 2a square. So we'll take 2a common. So it'll be y square 2a x minus a. So option number A, it matches with R. So A matches with R. Now the second question is, we need to find locus of midpoint of normal chord. So we have this parabola and then we have this normal chord, which is at1 square twice at1 and at2 square twice at2. And for normal chord, we know that t2 is minus t1 minus 2 upon t1. We need to find locus of midpoint. Say it is alpha and beta. So we can write alpha as a t1 square plus t2 square upon 2, and we can write beta as a t1 plus t2. So we can write this as 2 alpha upon a, and we'll add 2 t1 t2. So it will be t1 plus t2 whole square minus 2 t1 t2, and here t1 plus t2, it will be beta upon a. Now from here we can also write t1 plus t2 as minus 2 upon t1. So we'll replace the value of t1 plus t2, then we can write beta upon a is minus 2 upon t1. So basically t1 will be minus 2a upon beta. Now once we have t1, we can also find t1 t2. So we'll multiply t1, we can write t1 t2 as minus t1 square minus 2. So it'll be minus and then 4a square upon beta square minus 2. So now we'll put the value of t1 plus t2 and t1 into t2. So it'll be 2 alpha upon a, and this is t1 plus t2 square. t1 plus t2 square is beta upon a square. So it'll be beta square upon a square minus 2 t1 t2. So it'll be minus and minus will be plus. So it'll be 8a square upon beta square plus 4. Now we'll take a square beta square as LCM. So we'll get 2 alpha upon a, and will be beta to the power 4 plus 8a to the power 4 plus 4 a square beta square upon a square beta square. Now a and a square, so we'll cancel. So we can write this equation as 2a alpha beta square equals beta to the power 4 plus 4 a square beta square plus 8 a to the power 4. Now we'll take everything on the right hand side. Then we can write this equation as beta to the power 4, and then we'll take 2a beta square common, and we'll get 2a minus alpha plus 8a to the power 4 equals to 0. Now in the end, we'll replace beta with y and alpha with x. So this equation will be y to the power 4 plus 2a y square 2a minus x plus 8a to the power 4 equals to 0, and that's your option S. So that means B, it is matched to S. Now the third question is, we need to find locus of midpoint of chord for which line joining origin to extremities of chord are equally inclined to the axis of parabola. So we have this chord, and line joining these extremities, they are equally inclined to coordinate axis. So we know that if the lines are equally inclined to coordinate axis, then its slope will be plus 1 and minus 1. For this chord, say AB, this slope is m1, and this is a t1 square twice a t1, and this is a t2 square twice a t2. So if we'll find the slope, it will be 2a upon t1, it is 1. So we can write t1 as 2a, and in the same way 2a upon t2 is minus 1. We'll write t2 as minus 2a. Now we need to find locus of midpoint. So alpha is a t1 square plus t2 square upon 2 and beta is a t1 plus t2. Now t1 plus t2 is actually 0. So we'll get this locus as beta equals 0, which is simply y is equal to 0, and that's your option number B. Now the fourth one is we need to find locus of midpoint of the chord whose length is L. So again we'll get this alpha as a t1 square plus t2 square upon 2, and we'll get beta as a t1 plus t2. Now from here we'll write t1 square plus t2 square, it is 2 alpha upon a, and t1 plus t2 is beta upon a. Now we'll square it, we'll get t1 square plus t2 square plus 2t1 t2, and will be equal to beta square upon a square. Now we'll put the value of t1 square plus t2 square, then we can write 2t1 t2 as beta square upon a square minus 2 alpha upon a. Now we have t1 plus t2 and we have 2t1 t2. We need to find locus of midpoint of chord whose length is L. So we know that formula for length of the chord is L equals a t2 minus t1 under root of t1 plus t2 whole square plus 4. Now we'll square it. If we'll square it, we'll get L square equals a square, and will be t2 minus t1 whole square. And this is t1 plus t2 whole square plus 4. So we can write this equation as L square is equal to a square. Now t1 minus t2 whole square, we can write t1 plus t2 whole square minus 4 t1 t2, and here it will be t1 plus t2 whole square plus 4. t1 plus t2 is nothing but beta upon a. So we can write this equation as L square equals a square, and now t1 plus t2 will be beta upon a. So it will be beta square upon a square minus 4 t1 t2. Minus 4 t1 t2 will be minus 2, and then beta square upon a square minus 2 alpha upon a, and again here it will be beta square upon a square plus 4. Now we'll take LCM and simplify. We'll write this as L square equals a square, and it will be 4a alpha minus beta square upon a square, and it will be beta square plus 4a square upon a square. Now a square will cancel. We can write this equation as a square L square equals 4a alpha minus beta square and beta square plus 4a square. Now we'll replace alpha with x and beta with y. So its equation will be a square L square 4ax minus y square into y square plus 4a square. So that is the locus of required midpoint. And that's your option number Q. So that means this D, it is matched to Q. For the parabola, y square equals 4ax, a normal chord AB is drawn at a point A such that AB is shortest. So basically here we are talking about the shortest normal chord. And then we need to find circumcenter of this triangle OAB. Now we have this parabola, which is y square equals 4ax. And then we have this normal chord, which is AB. Now we want this normal chord to be of shortest length. So in one of the previous video, we have already discussed that length of a normal chord is given by 4a t1 square plus 1 to the power 3 by 2 upon t1 square if it is drawn at this point, which is a t1 square twice a t2. And suppose this other end is a t2 square twice a t2. Now we need to minimize it. So what we'll do is we'll square it and then we'll differentiate. So we'll write L square as 16a square t1 square plus 1 whole cube upon t1 to the power 4. Now we'll differentiate with respect to t1. So we'll write 2l dl upon dt1. It'll be 16a square, and then we can write t1 to the power 4 3 t1 square plus 1 whole square into 2t1, and then minus it'll be t1 square plus 1 whole cube into 4 t1 cube. Now we'll take 2 t1 cube and t1 square plus 1 whole square common. So we'll take it common. We'll write 16a square, and then we'll write 2 t1 cube and then t1 square plus 1 whole square. So then we'll get 3t1 square and then minus 2 t1 square plus 1. And for maxima and minima, we'll need to find its critical point. So we'll put it equals to 0. Then we'll get 32a square t1 cube t1 square plus 1 whole square, and then it will be t1 square minus 2 equals to 0. So we'll get value of t1 as plus or minus root 2, and we'll also get t1 as 0. So we'll plot these roots on a number line. We'll get minus root 2, 0, and plus root 2. Rightmost is plus, so it is plus, and minus. So we'll get a minima when the value of t is either plus root 2 or minus root 2. So length of this normal chord, it will be minimum when the value of t1 is, say, root 2. So if the value of t1 is root 2, we can write this point a as at1 square twice at1. So it will be 2a and 2 root 2a. Now we'll write this point b. Now we know that relationship between t1 and t2 is t2 equals minus t1 minus 2 upon t1. So we'll put t1 as root 2. We'll write minus root 2 and then minus root 2. So actually value of t2 is minus 2 root 2. So now we can write b also. So coordinate of this point b, it will be at square. It will simply be 8a, 2at2. So it will be minus 4 root 2a. Now we need to find circumcenter of this triangle OAB. Now we'll find slope of OA. So we know that slope of OA is 2 root 2a upon 2a. So it'll simply be root 2, and we'll find slope of OB. Slope of OB is minus 4 root 2a upon 8a. So it'll be minus 1 upon root 2. So we look at it, we'll find m1 into m2 is minus 1. So if product of slope is minus 1, it means this angle is 90 degrees. So this triangle OAB, it is a right angle triangle. Now in a right angle triangle, circumcenter is midpoint of hypotenuse. So that means circumcenter of this triangle OAB, which is say S, it is given by midpoint of A and B. Now A is 2A and B is 8A. So S is given by 2A plus 8A by 2, and then 2 root 2A minus 4 root 2A by 2. So circumcenter of this triangle will be at 5A minus root 2A. Now we'll take T as minus root 2, then we'll get another result, and I think that result will be 5A comma root 2A. So there'll be two answers possible in this question. Now here the question is, find the minimum value of x1 minus x2 square plus 12 minus under root of 1 minus x1 square minus under root 4x2 whole square. Now if we look at this formula closely enough, it looks like distance formula, which is x1 minus x2 square plus y1 minus y2 square. We can write y1 as 12 minus under root of 1 minus x1 square, and we can write y2 as under root of 4x2. So if we'll square it, we can write this as x1 square plus y1 minus 12 whole square is equal to 1. And here it will be y2 square equals 4x2. Now this first point, it lies on this circle which is x square plus y minus 12 square equals 1. And second one, it lies on this parabola which is y square equals 4x. Now we need to find minimum value of this expression, which actually is square of shortest distance between these two curves. So we need to find square of shortest distance between this circle and parabola. Now we know that shortest distance, it occur along common normal. So any normal to this circle, it'll pass through its center, which is 0, 12. And for this parabola, value of a is 1. Equation of normal for this parabola will be y equals mx minus am cube minus 2am. Now we need that normal of parabola which passes through 0, 12. So we'll put x as 0 and y as 12. So it'll be 12 and it is minus m cube minus 2m. So we can write this equation as m cube plus 2m and then plus 12 equals 0. If we'll put m as minus 2, we can write minus 8 minus 4 plus 12 equals to 0. So that means one of the root is minus 2 and we can use synthetic division. So this is minus 2 and it is 1, 0, 2 and 12. So it is 0, 1, minus 2. So it will be minus 2, 4, 6, minus 12, 0. So we can write this equation as m plus 2 and then m square minus 2m plus 6 equals to 0. Now for this equation, there's no real root. So the only value of m that we'll get here is minus 2. So the value of m is minus 2. Now once we have this m, we can write foot of normal. So let that point be P. So foot of normal is am square, so which is 4 and then minus 2am. So minus 2am will be simply 4. So the point on this parabola which is closest to this circle is 4, 4. So now we have this circle having center at 0, 12 and radius is 1, and then we have this parabola and the point which is closest to it is 4, 4. Now we need to find this shortest distance. So what we'll do is we'll find distance between center and this point P. So we'll find CP. So CP in this case will be 4 square plus, now this is 12, 12 minus 4, it is 8, 8 square is 64. 64 plus 16 is under root 80 and 80 is 4 root 5. So this is 4 root 5. So this distance CP, it is 4 root 5 and radius of this circle is 1. So the shortest distance which is D, so shortest distance between this circle and parabola will be 4 root 5 minus 1. Now in this question we need square of this minimum distance. So D square, it will be 4 root 5 minus 1 whole square, and that is the answer to this question. Now here the question is, find the minimum distance between the curves y square equals x minus 1 and x square equals y minus 1, and say the distance is D. We need to find the value of 2 root 2 into D. So first we have this parabola which is y square equals x minus 1. So parabola opening right and shift it to 1, 0. And then we have this parabola which is x square equals y minus 1. So parabola opening upwards, again shifted 1 units. Now we need to find minimum distance between these two curves. Now what we know is minimum distance, it occurs along a common normal. Now we need to find common normal between these two parabolas. But in this question, solving common normal wouldn't be that easy because here we have this first form and third form, and this equation will be really complicated. But if we look at these two equations, y square equals x minus 1 and x square equals y minus 1, they're closely related. If we'll interchange x and y, then From first we'll get second equation, and from second we'll get first equation. So basically these two parabolas, they are inverse parabolas of each other. So basically they are reflection of each other about this y equals x line. So these two parabolas, they are reflection of each other about y equals x line. Now this line of common normal will also be perpendicular to this line, which is y equals x. So slope of this line is 1. So we need to find points on these curves, say A and B, whose slope of normal is simply -1. Now since the situation is symmetric about y equals x line, what we'll do is we'll find this distance, and then the shortest distance between these two parabolas will be double of it. Now for this parabola, y square equals x minus 1. We know that foot of normal, which in this case is B, will be given by, now since it is x minus 1, so it will be 1 plus am square. So 1 plus am square and then minus 2am. Now a in this case is 1 by 4 and the value of m is simply -1. So we can write the coordinate of this point B as 1 plus 1 by 4, comma, now it will be m minus plus will be 1 by 2. So coordinate of this point B, it will be 5 by 4, comma, 1 by 2. Now we can find this distance, which is d by 2. So this distance is perpendicular distance of this line x equals y from this point, which is 5 by 4, comma, 1 by 2. So this d by 2, it will be 5 by 4 minus 1 by 2 upon root 2. So it will be 3 upon 4 root 2. So we can write 2 root 2 into d. This value is equal to 3. So the answer to this question is the value of 2 root 2 d is 3 units. Now this is an interesting question involving complex numbers and parabola. It says, let z be a complex number of maximum amplitude satisfying mod of z minus 3 is equal to real part of z. Then we need to find the value of mod z minus 3. So first we'll simplify this equation. So what I'll do is I'll let z as x plus iota y. So then we can write x minus 3 plus iota y is equal to real part of z, which is x. So we'll find its magnitude and we'll square it. So we'll write x minus 3 square plus y square is equal to x square. So we'll get x square plus 9 minus 6x plus y square is equal to x square, which will get cancelled. So we'll write y square equals 6x minus 9, or y square is 6 and then x minus 3 by 2. If we'll compare it with the standard parabola, then it will be y square equals 4a capital X. And in this case, value of a is simply 3 by 2. So we have this parabola whose vertex is at 3 by 2, comma 0. So we'll draw this parabola. Now on this parabola, we need a point Z having maximum amplitude. We know that amplitude is nothing but angle that a point makes with positive real axis. So if we look at these points, then we know that this angle, it is increasing. Then we'll have one point where this argument will be maximum. So this argument will be maximum at a point P, at which tangent drawn will pass through origin. So we'll need to find coordinate of this point P. So once we have equation of this parabola, we can write equation of tangent as y equals m. Now in place of x, we can write x minus 3 by 2, and then plus a by m. Now a in this case is 3, so it will be 3 by 2m. We'll need that tangent which passes through origin. So we'll put x and y as 0. So we'll put x and y as 0. We'll get 0 equals minus 3m by 2 plus 3 by 2m. So from here we'll get the value of m as plus or minus 1. Now, since we need z of maximum amplitude, we'll take m as plus 1. So for this z, value of m is plus 1. Now, once we have this slope, we can write this point of contact. So this point of contact will be x equals a by m square. Now x in this case is x minus 3 by 2, and it should be equal to a by m square, and then y equals 2a by m. Now we'll put the value of a and m. Now a is 3 by 2 and m is 1. So we'll get x as 3 and y as 3. So this point P, its coordinate will be 3, 3, and this z is 3 plus 3 iota. Now we need to find the value of mod z minus 3. So mod z minus 3, it will simply be mod of 3 iota, and mod of 3 iota is 3. So answer to this question is 3. Now here the question is, let z be a complex number satisfying this equation, which is mod of z minus 2 is equal to real part of z. Then we need to find minimum value of mod z minus 4. Now we are given that mod of z minus 2 is equal to real part of z. So we'll take z as x plus iota y. Now we can write this as mod of x minus 2 plus iota y, and real part of z, it is simply x. So it will be under root of x minus 2 square plus y square equals x. So we can write x square plus 4 minus 4x plus y square equals x square. So we write this equation as y square equals 4 x minus 1. So basically z lies on this parabola whose focus is at 1, 0. So we'll draw this parabola. It says we'll need to find minimum value of mod z minus 4. So in complex numbers, we know that modulus is basically distance between 2 points. So one of the point is z, which lies on this parabola, and another point is 4, which lies on axis of this parabola. So we need to find the minimum value of this distance between a point on parabola and this fixed point. Now we have already studied that minimum distance will occur along a normal which will pass through this point. So what we'll do is, for this parabola, we'll write equation of normal. So for this parabola, equation of normal will be y equals m. Now in place of x, we'll write x minus 1 minus am cube. A in this case is 1. So it'll be m cube minus 2m. We need that normal which passes through this point 4, 0. So we'll put y as 0 and x as 4. So it'll be 0. And then 3m minus m cube minus 2m. So it'll be m cube minus m equals to 0. We'll get 3 values of m. Either m is 0 or m is 1 or m is minus 1. Now 3 normals can be drawn from this point 4, 0. We need to find shortest distance from this parabola. So we'll write foot of all the 3 normals. So we know that foot of normals is given by am square minus 2am for a parabola which is y square equals 4ax. But we have a parabola which is y square equals 4x minus 1. So in this case, foot of normal will be given by 1 plus am square minus 2am. Now for this parabola, value of a is 1. So now we'll start putting the value of a and we'll start putting in the value of m. So we'll take m as 0. We'll get this point as, say, a, and it will be simply 1, 0. If we'll put m as 1, then we'll get this point, say b. So a is 1 and m is 1. So it will be 2, -2. So b is 2, -2. And then we'll find this point which is c when the value of m is -1. So we'll put m as -1. We'll get this point c as 2, 2. So this point, it will be 2, 2. Now we'll find all these three distances and then we'll see which is the minimum distance, and there will be the minimum value of mod z minus 4. So we'll find this AP. So this AP is simply 4 minus 1 and that is 3. And from symmetry we can say that BP must be equal to CP, and this value, it will be under root of 2 square plus 2 square, and that should be 2 root 2. So the minimum value of mod z minus 4 will be simply 2 root 2, and that is the answer to this question. Now this third question is, we are given a set which is sigma, which is set of all complex numbers x plus iota y such that mod y is less than or equal to 1, and then we are given this function which is fz, and that is z square plus 2. Now it says draw a sketch of f sigma which is fz for all z belongs to sigma. So that means for all the complex numbers z present in this set, we need to draw the sketch of fz. Now first we'll look at input values. Now this sigma, it contains all the values of x and y such that mod y is less than or equal to 1. So when mod y is less than or equal to 1, it means value of y should lie between -1 and +1. So its domain spaces within these two lines, which are y equals 1 and y equals -1. So we are talking about all the points in this shaded region. Now we'll put the points from domain in this function, then it will transform into an output space. Suppose u plus iota v. So we'll write this fz as sum u plus iota v, and it is z square. Z is x plus iota y whole square plus 2. So we'll write this as u plus iota v, and it'll be x square minus y square plus 2 xy iota. Now we need to draw sketch of u and v. Now comparing real and imaginary part, we can write u as x square minus y square plus 2, and we'll write v as 2xy. Now the condition given in the question is this mod of y is less than or equal to 1. Now what we'll do is we'll begin with the boundary cases. The boundary cases which are when the value of y is 1, when the value of y is -1, also when the value of y is 0. So when the value of y is 1, in that case u will be x square plus 1 and v, it will be 2x. So we can write this x as v by 2. So we'll write this as v square by 4 plus 1. So we'll get this parabola which is v square equals 4u minus 1. So we'll take this boundary condition when the value of y is 1. We'll end up getting this parabola which is 4u minus 1. Now we'll take y as -1. If we'll take y as -1, again we'll get u as x square plus 1 and v is -2x. Again we'll replace x with minus v by 2. So we'll get u equals v square by 4 plus 1. So again we'll get v square equals 4u minus 1. So that is for both the boundary values 1 and -1, we are getting the same parabola which is v square equals 4u minus 1. Now we'll put y as 0. In that case, we'll get u as x square plus 2 and v as 0. In that case, we'll get a ray lying on x-axis and which is greater than or equal to 2. Its y coordinate will be 0. Now what we'll do is we'll plot these three sketches. Now this is u and this is v. Now this is y square equals 4ax. So it represents a parabola opening rightwards and shifted 1 units to the right. So we can draw this parabola as v square equals 4 into u minus 1. Now second one, it's again the same parabola. And this third one is u equals x square plus 2. So in this case, u will be greater than or equal to 2 and v is 0. So I'll represent this ray starting from 2 and going towards infinity. So this is the sketch of boundary values. Now we need to find this complete region. Now we know that this u is x square minus y square plus 2 and v is 2xy. So we'll square this second equation. We'll get v square equals 4x square y square. Now in the question it says mod of y is less than equal to 1, which simply means y square is less than equal to 1. So we can write v square is less than or equal to 4x square. Now from this first equation we can write y square, it is x square plus 2 minus u, and again it is less than or equal to 1. So from here we'll write x square is less than or equal to u minus 1. So now we have two inequality relationships, which is v square is less than equal to 4x square and x square is less than u minus 1. So from these two we'll get this condition, which is v square is less than or equal to 4 u minus 1. So that means for all the points in this input space, we are getting a condition where v square should be less than or equal to 4 u minus 1. So if we'll take any point, say origin, if we'll put v as 0 and u as 0, we'll get 0 is less than equal to minus 4, which is incorrect. So that means we are talking about region other than origin. So the sketch of output space is this parabola and points lying inside of this parabola. And that is the answer to this question. Now here the question is, if the tangent at the point t square comma 2t on the parabola y square equals 4x is same as normal drawn at point root 5 cos theta comma 2 sin theta on the ellipse, 4x square plus 5y square equals 20, then which of the following is correct? Now we know that equation of tangent to parabola is ty equals x plus 8t square. So at any point t, this is equation of tangent. Now equation of normal drawn at any point on this ellipse is ax secant theta. Now a in this case is under root 5 and b is 2. So it will be root 5 secant theta x minus 2 cosec theta y, and it will be equal to a square minus b square, which is simply 1. Now these two equations, they represent the same line. So we can rewrite this first equation as x minus ty plus at square equals to 0. And the same way we can write the second line as root 5 secant theta x minus 2 cosec theta y and minus 1 equals 0. Now since they are coincident lines, we can write root 5 secant theta upon 1 equals minus 2 cosec theta upon minus t, and it will be equal to minus 1 upon 8t square. We'll take these first two expressions, then we can write t as 2 upon root 5 cos theta upon sin theta, and if we take second and third, then from there we can write t as Now value of a for this parabola is simply 1. So we'll take this a as 1. So we can write this t as minus sine theta by 2. Now we'll eliminate this t. So we'll eliminate this t, then we can write 2 cos theta upon root 5 sine theta, and it is equal to minus sine theta upon 2. So we can actually write this as 4 cos theta, and this is minus root 5 sine square theta. We can write sine square theta as 1 minus cos square theta. So we'll write 4 cos theta minus under root 5 and 1 minus cos square theta. Now it has become a quadratic equation in cos square theta. So it will be root 5 cos square theta minus 4 cos theta minus under root 5 equals to 0. Now from here we'll get two values of theta. So either the value of cos theta is minus 1 by root 5 or value of cos theta is under root 5. Now cos theta cannot take the value root 5. So from here what we'll get is value of cos theta should be minus 1 by root 5, and that's your option number A. Now the value of cos theta is minus 1 by root 5, then the value of sine theta, it will be 2 by root 5. Now we'll put sine theta as 2 by root 5, we'll get value of t as minus 1 by root 5. So that means value of t should be minus 1 by root 5, and that's your option number D. So the correct answer to this question is option A and option D. So let us take a problem, and the question is a movable parabola touches the x-axis and y-axis at 1, 0 and 0, 1. Then the locus of the focus of the parabola is. So we need to find locus of focus of this parabola. So first we'll draw this parabola. So now we have a parabola which touches both the axes. So it touches x-axis at 1, 0, and it touches y-axis at the point 0, 1, and we need to find locus of its focus. So suppose focus is alpha, beta. So now we know that the property is reflection of focus about any tangent to a parabola will always lie on directrix of a parabola. So we'll take reflection of S about this tangent, which is y-axis. Then suppose this point is S1. So its coordinate will be minus alpha, beta. And we'll take reflection of S about other tangent, which is x-axis. Then we'll get S2, and which is alpha, minus beta. So now we have 2 points on directrix. We can write equation of directrix from this. So equation of directrix for this parabola will be y minus beta. Now what is the slope? Slope is 2 beta upon minus 2 alpha, and then x plus alpha. So 2 and 2 will cancel. So I get minus alpha y plus alpha beta, and this is beta x plus alpha beta. So equation of directrix will be beta x plus alpha y is equal to 0. Now it's a locus problem. We need to find relationship between alpha and beta. Now we know that distance of any point from focus is same as distance from directrix. So for this point 0, 1, if we'll write this distance, we'll write this distance as under root of alpha square plus beta minus 1 whole square, and it should be equal to distance of this directrix from 0, 1. So we'll take distance from 0, 1, then we'll get alpha upon under root of alpha square plus beta square, and in the same way if we'll take distance from this point 1, 0, then in that case we'll get under root of alpha minus 1 whole square plus beta square, and this should be beta upon under root of alpha square plus beta square. Now what we'll do is we'll square and add the two equations. So we'll square and add the two equations. We'll write this as alpha square plus beta minus 1 square plus alpha minus 1 square plus beta square, and here we'll get alpha square plus beta square upon alpha square plus beta square, which is 1. So we can write this equation as 2 alpha square plus 2 beta square minus 2 alpha minus 2 beta, and this is 2 minus 1, and then it will be plus 1. So the locus of focus of this parabola, it will be 2x square plus 2y square minus 2x minus 2y plus 1 equals to 0. Now here the question is, normals are drawn from point 4, 1 to the parabola y square equals 4x. The tangent at the feet of normal to parabola y square equals to 4x form a triangle ABC. So first we'll find equation of normal. So for this parabola, value of a is 1. So we'll write equation of normal in parametric form. So equation of normal in parametric form will be y plus tx equals at cube, and a here is 1 plus 2at. So there'll be simply 2t, and we need normals passing through 4, 1. So we'll put x as 4 and y as 1. So it'll be 1 plus 4t, and this is t cube plus 2t. So it'll be t cube minus 2t minus 1 equals to 0. Now we can add 1 and subtract 1. So we can write this as t cube plus 1. So it'll be t plus 1, and then t square minus t plus 1, and then minus 2, and it'll be t plus 1. So we can write this as t plus 1 and t square minus t minus 1 equals to 0. So value of t is minus 1, or the value of t is 1 plus minus under root 5 upon 2. So now we have t1, t2 and t3. Suppose t1 is minus 1, t2 is 1 plus under root 5 upon 2, and t3 is 1 minus under root 5 upon 2. Now we know that these point of intersection of tangents is a t1 t2 and a t1 plus t2. So we'll write these point of intersections as, suppose a is t1 t2. t1 t2 is minus 1 minus root 5 by 2, and then t1 plus t2. So we'll add them. We'll get minus 1 plus under root 5 by 2. Now b will be t2 t3, 1 minus 5 minus 4 upon 4 will be minus 1, and then t1 plus t2. So it will be minus 1 comma 1, and c will be t1 t3. So it will be minus 1 plus root 5 upon 2, and then t1 plus t3. So it will be minus 1 minus under root 5 by 2. Now first we'll find centroid of this triangle. So centroid of this triangle will be, now we'll add the x coordinates. So it will be root 5 by 2 will cancel. So we'll get minus 1 and then minus 1. So it will be minus 2 by 3, and its y coordinate, it will be, now root 5 by 2 will cancel. So it will be 0. So distance of focus from centroid. So we know that for this triangle, focus is at a comma 0. So it will be at 1 comma 0. So distance of focus from centroid, it will simply be mod of 1 plus 2 by 3. So it will be 5 by 3. So option A, it matches to 5 by 3. Now the second question is distance of focus of this parabola from orthocenter of triangle ABC. Now we look at this T2 and T3. Then if we will multiply T2 into T3, we know that this value will be minus 1. When T2 into T3 is minus 1, so it simply means that these two tangents, they are perpendicular. So this triangle ABC will be a right angle triangle, and point of intersection of T2 and T3 is B, which is minus 1 comma 1. So that means orthocenter of this triangle is at minus 1 comma 1. So distance of focus from orthocenter, so it will be simply bs and will be under root of, now this is 2 square and then plus 1 square, so it will be simply root 5. So distance of focus from orthocenter of triangle ABC is simply root 5. That's your option number D. Now the third question is distance of focus of parabola from circumcenter of triangle ABC. Now since this triangle ABC, it's a right angle triangle, then its circumcenter is actually midpoint of hypotenuse. So let circumcenter be some C dash. So C dash is midpoint of AC. Now what's A? A is minus 1 minus root 5 by 2 and C is minus 1 plus root 5 by 2. So we'll find its midpoint. So root 5 by 2 will cancel. So it will be minus 1. So it will be minus 1 by 2. So again for y coordinate root 5 by 2 will cancel. So again it will be minus 1 by 2. So distance of circumcenter from focus will be under root of, now 1 minus 1 by 2 will be 3 by 2. So 3 by 2 square is 9 by 4 plus 1 by 4. So it should be under root of 10 by 4, which is simply root 5 by 2 or under root 10 by 2. And that's your option Q. And now this last one, which is area of triangle ABC. Now area of triangle formed by tangents is given by 1 upon 2 a square, and then it is t1 minus t2, t2 minus t3, and then t3 minus t1, its modulus value. So it will be 1 by 2. Now a in this case is simply 1. Now here t1 is minus 1, t2 is 1 plus root 5 by 2, and t3 is 1 minus under root 5 by 2. Now what's t1 minus t2? t1 minus t2 will be minus 3 minus root 5 by 2, and then t2 minus t3. t2 minus t3 will be simply root 5 and then t3 minus t1. So it will be 3 minus root 5 by 2 and its absolute value. So it will be 1 by 8 and then root 5, and this is a plus b, a minus b. So there will be 9 minus 5. So it should be 4. So its area should be root 5 by 2. So area of triangle ABC is under root 5 by 2, and that's your option S. Now let us take another question, which is a ray of light is coming along a line y equals 2 from the positive direction of x-axis and strikes a concave mirror whose intersection with xy plane is a parabola y square equals 8x. Then we need to find equation of the reflected ray. So we have this parabola which is y square equals 8x, and then we have this incident ray which is coming along the line y equals 2. So we can find this point. For this point, y coordinate is 2. So we'll put y as 2. We'll get x as 1 by 2. So this point will be 1 by 2, comma 2. Now after reflection, it will pass through focus of parabola. So we know that focus of this parabola will be at a comma 0. So it will simply be 2 comma 0. We'll need to find equation of this line. So we'll find its slope. So its slope will be 2 upon 1 by 2 minus 2. So it will simply be minus 4 by 3. So we can write this equation as y minus 0 minus 4 by 3 x minus 2. So it will be 4x plus 3y minus 8 equals 0. And that's your option number C. Now the next question is a ray of light moving parallel to x-axis gets reflected from parabolic mirror whose equation is y square plus 10y minus 4x plus 17 equals 0. After reflection, the ray must pass through the point. So we know that any line which is parallel to x-axis, which actually is axis of this parabola, it should pass through focus of this parabola. So all we need to do is we need to find focus of this parabola. So we can write this equation as y square plus 10y minus 4x plus 17 equals 0. Now we'll complete its perfect square. So we'll add 25 and we'll subtract 25. So we'll write this equation as y plus 5 whole square and minus 4x minus 8 equals to 0. So equation of this parabola is y minus 5 whole square equals 4 x plus 2. For this parabola, we need to write its focus. So we know that focus is at a comma 0. So capital X equals a and capital Y equals 0. So x in this case is x plus 2, a is 1 and y is y plus 5 equals 0. So focus of this parabola will be minus 1 comma minus 5. So any ray which is parallel to axis of this parabola must pass through focus of this parabola, which is option number B. Now the third question is, a ray of light is coming along the line x equals lambda and lambda is less than 0 from positive direction of y-axis and strikes a concave mirror x square equals 4y minus 1. So it represents a parabola opening upwards and whose focus is at 0, 1. So we'll draw this parabola. So this is the equation of parabola, which is x square equals 4 y minus 1. Now a ray of light is coming along the line x equals lambda, where lambda is less than 0. So we have this light. So we have this ray of light which is parallel to axis of this parabola. It will pass through its focus and it says the ray reflected from it is x plus y equals 2. So equation of this line is x plus y equals 2. So what we'll do is, first we'll write focus of this parabola. So we know that this is third form of parabola, and for the third form focus is 0, a. So capital X equals 0 and capital Y equals a. Now x in this case is simply x and y is y minus 1 and a is 1. So this point, it is 0, 2, and clearly reflected ray, it passes through focus because it satisfies this equation. Now any ray which passes through focus will again be parallel to axis of this parabola. So what we need to do is, we need to find this point of intersection. So we'll find point of intersection of this line, which is x plus y equals 2 with parabola, that is x square equals 4 y minus 1. Now we'll write y minus 1 as 1 minus x. So we'll replace y minus 1 with 1 minus x. We'll write this equation as x square, and this is 4 minus 4x. So it'll be x square plus 4x and plus 4 equals 8. So we'll write this equation as x plus 2 whole square equals 8. Value of x should be minus 2 plus minus 2 root 2. Now since we are talking about this line, and for this line x should be positive, so its equation will be x equals minus 2 plus 2 root 2, and that's your option number D. Now let us take a very interesting question, and that is, if y equals x plus 1 is the axis of parabola, y plus x equals 4 is tangent to the same parabola at its vertex, and y equals 2x plus 3 is one of its tangent, then we'll need to find equation of directrix, length of latus rectum, extremities of latus rectum, and the equation of parabola, which is in the form of x minus y plus 1 square equals b upon a, x plus y minus 4 square. Now how do we solve this question? First we'll draw this parabola. We have coordinate axis, and then we have this line y equals x plus 1. This is y equals x plus 1, which is axis of parabola, and then we have y plus x equals 4, which is tangent at vertex, and then we have this parabola, and it also says one of the tangent to this parabola is y equals 2x plus 3. So one of the tangent it is y equals 2x plus 3. Now first we'll find vertex of this parabola. So we'll solve these two equations. So we have y equals x plus 1 and y plus x equals 4. So we'll put y as x plus 1. We'll get 2x equals 3. So its x coordinate will be 3 by 2. And if we'll put x as 3 by 2, then we'll get y as 5 by 2. Vertex of this parabola is at 3 by 2, 5 by 2. Now next we'll find focus of this parabola. Now we'll say, suppose the focus is h, k. Now this focus, it lies on axis. So we can write h minus k plus 1 equals to 0. So that's my equation number 1. And then we also know that this foot of perpendicular from focus to any tangent, it will lie on tangent at axis. So we'll first find this point of intersection. So this point of intersection, we'll find it through this tangent at vertex, which is y plus x equals 4, and then this tangent, which is y equals 2x plus 3. So we'll replace y with 4 minus x. So we'll get x as 1 by 3. So say this point is A. So the coordinate of this point A is 1 by 3 and 11 by 3. Now we know that this perpendicular from focus on this line is A. So that means we'll take product of slope and we'll put it equals to minus 1. So then will be k minus 11 by 3 upon h minus 1 by 3 into, what is the slope of this line? Slope of this line is 2. And this is equal to minus 1. So we'll get this as 6k minus 22, and this is minus 3h plus 1. So we'll get this equation as h plus 2k equals 23 by 3. So now we have two equations. So if we'll solve these two equations, we'll get the value of h and k. We'll write this equation as minus h plus k is equal to 1. So we'll add them, we'll get the value of k. We'll get 3k equals 26 by 3. So that is the value of k is 26 by 9. And if we'll put the value of k in this equation, we'll get h as 26 by 9 minus 1, which is 17 by 9. So focus of this parabola is at 17 by 9, 26 by 9. So focus is at 17 by 9 and 26 by 9. So we'll write the result here. So we have vertex. Vertex is at 3 by 2, 5 by 2. And focus is at 17 by 9 and 26 by 9. Now we'll need to find equation of directrix. So we'll find base of directrix. So suppose this is our directrix. We'll find base of directrix. Suppose this point is D. So we know that vertex is midpoint of D and S. So if we'll take D as, say, x1, y1, then x1 plus 17 upon 9 by 2 is equal to 3 by 2, and then y1 plus 26 by 9 by 2 is equal to 5 by 2. So we'll get x1 as 10 by 9, and we'll get y1 as 19 by 9. So basically base of directrix is 10 by 9 and 19 by 9. Now we can start solving this question. Now the first thing that we need to find is equation of directrix of parabola. So directrix is a line which is parallel to tangent at vertex. So slope of this line is -1. So that means slope of directrix is also -1. So equation of directrix will be y minus 19 by 9 and minus x minus 10 by 9. So we'll get this equation as x plus y, and this is 29 by 9. So we can write this equation as 9x plus 9y minus 29 equals to 0. And the condition they have given is ax plus by minus 29 equals to 0. Then a plus b is. So a is 9 and b is 9. A plus b is 18. So this option A, it is matched to Q. Now for the second one, we need to find length of lattice rectum. So we know that distance between vertex and focus is equals to A. So we'll find this distance. Say we'll find VS, which is A, and it is under root of, and this is 17 by 9 minus 3 by 2 square and plus 26 by 9 minus 5 by 2 square. So we'll get this as 32 minus 27. So that's 7 square 49 by 18 square. And here will be 52 minus 45. So again there'll be 49 by 18 square. So we can write it as 7 root 2 by 18. Now we need to find length of lattice rectum. Length of lattice rectum is 4a. So it will be 14 root 2 by 9, which they have given as a root 2 by b. So it is a root 2 by b. So here a is 14 and b is 9. And then what is a plus b? A plus b in this case is 23. So that means b is mapped to R. Now the third thing that we need to find is extremities of lattice rectum. So we know that lattice rectum is a line which passes through focus and is perpendicular to axis. So what we'll do is we'll say this point is suppose alpha comma beta, and it is at a distance of 2a. And what's 2a? 2a is 7 root 2 by 9 units. So we'll find foot of perpendicular from this point alpha beta on this line, which actually is focus. So we can write this foot of perpendicular as x minus alpha upon 1 y minus beta upon minus 1, and then this distance which is minus. Now we can have 2 points, one up and one down. So we can write it as plus minus 7 root 2 by 9. Now x here is 17 by 9. So we can write 17 by 9 minus alpha equals plus minus 7 root 2 by 9. And this is 26 by 9 minus 26 by 9 plus beta. And this is plus minus 7 root 2 by 9. So here alpha is 17 by 9 plus minus 7 root 2 by 9, and beta is 26 by 9 plus minus 7 root 2 by 9. Now we need to find greatest interior function of a1 plus b1 plus a2 plus b2. So we need to find greatest interior function value of, this is 17 by 9 plus 7 root 2 by 9, and then 17 by 9 minus 7 root 2 by 9. Here it is 26 by 9 plus 7 root 2 by 9, and then 26 by 9 minus 7 root 2 by 9. So 7 root 2 by 9 will cancel. Here it will also cancel. So we'll get this value as 34 by 9 and plus 52 by 9, and which is 86 by 9. 86 by 9 is 9 point something. So its greatest interior function value is 9. So that means this value, it is mapped to P. Now the last one is, if the equation of parabola is x minus y plus 1 square, and this is b upon a, x plus y minus 4, then we need to find the value of b upon a. So we'll compare it with the standard equation, which is capital Y square equals 4a capital X. Now here capital Y is x minus y plus 1 and capital X is x plus y minus 4, and here a is b upon 4a. Now we know that focus of this parabola is at a comma 0. So that means capital X equals a and capital Y equals 0. So we'll take capital X as a. So capital X is x plus y minus 4, and this is equals to b upon 4a. Now we already have focus of this parabola. So focus is at 17 by 9 and 26 by 9. So it will be 76 by 9 plus 26 by 9 minus 4, and this is b upon 4a. So it will be 43 by 9 minus 36, 7 by 9 equals b upon 4a. So we can write b upon a as 28 by 9. Now in this case, what is the value of a plus b? So in this case, value of a plus b will be 28 plus 9, and which is 37. So that means D is mapped to S.